So for our last example here, we get the equation where it's not in graphing form yet. So it will involve the completing the square process we saw back for the ellipse with one tiny little difference to pay attention to. So we will start with the x terms. And notice in this case, I've given them to you in the order where they're next to each other, but I still want that space. So I'll leave that space there. Now the minus 25y squared will go here with the 250y, leave a space, and move that 489 to the other side. So that step looks basically the same as we saw with the ellipse, which the next step will be the same as well, looking at GCFs. We want a GCF here of 4, so we get x squared minus 6x. Now here, we do definitely need the negative to be a part of this GCF. So the negative 25 being factored out, leaving me with y squared, and this will be a minus 10y there. And that'll equal 489. Now, the first one works just like we saw back with the ellipse. The complete the square process of negative 6. So half of negative 6 is negative 3, squared is plus 9. And as soon as we put that plus 9 there, we realize that what we've actually done is we've taken that 9 times the 4, so we've actually added 36 to this left side. And because of adding the 36, we want to come over here and add 36 as well. So we go to the complete the square on the y's. We have negative 10. Half of negative 10 is negative 5. Squared is 25. So plus 25. This plus 25, notice, is times a negative 25. So we have to keep in mind that what we've actually done here, even though we just put a plus 25, we have actually subtracted 625 from that left-hand side because of this negative 25 out front. So we will subtract 625 on that right-hand side. So that's the only difference, is just making sure you don't miss this subtraction, both as a GCF affecting that, but also especially as the affecting what we did to that left-hand side. Don't miss that detail. Beyond that, everything else is the same. We can factor this into the x minus 3 squared, factor that into the y minus 5 squared, combine those numbers on the right, and we'll get negative 100. So, negative 100 is a little interesting idea here. Let's deal with that negative 100. We do not want that to be negative. We need it to be positive. So we'll divide by negative 100. Right? Divide all these terms by negative 100. Now what that does is that gives us an x minus 3 squared over 25. And I'm going to put the negative out front there, because here the negative over the negative will make this a positive y minus 5 squared over 4 equals 1. And that's just a little different than we're used to, so I'm going to swap it and point out that that really means we've got y minus 5 squared over 4 minus x minus 3 squared over 25. It is pretty important that we get it arranged in a way that it's seen as a subtraction problem for this between these two terms, so we can really identify which variable came first, which kind of hyperbola we're dealing with, and all the rules of A and B as well. So just watch for that. That's not, it can happen, and if it does, here's how you resolve it. You divide by the negative, and then you basically need to swap those terms so you've got that subtraction where it needs to be. So from there, let's identify all the important characteristics. We've got the center. Notice with the y coming first, this is still the k, that is still the h. So x minus h means the center is a 3, comma, y minus k, the y coordinate 5. So center of 3, 5, so we can start there. 3, 5 for our center. We'll still use the a first and the b second, so a is 2 and b is 5, where a is associated with y, so up and down 2. B of 5 associated with x, so left and right 5. Now let's use those dimensions to draw our central rectangle and connect for our asymptotes. Kind of missed that corner there a little bit. Okay. And so with our asymptotes, we come back up here and again we say with this y term coming first, we expect this to be a vertical hyperbola. Meaning, for this graph, it's opening up and down, so that is going to be the location of our vertices, and they will asymptote off to the left and right. And with that, we can then identify the vertices. So notice they are at 3, 3 and 3, 7. So just the two up and down from our center of 3, 5. And then we need the foci. So we'll get c squared equals a squared plus b squared going. 2 squared plus 5 squared. So 4 plus 25. So c squared equals 29. So c equals the square root of 29. So the square root of 29 is going to be approximately 5.4, we'll say. We know these hyperbolas are going to graph or curve around the hyperbola. So the 5.4 is going up and down here. So 1, 2, 3, 4, 5. In fact, the 5.4 is actually almost off the chart here. 5.4 is going to be up here, and 1, 2, 3, 4, 5, yep. So a little bit off the graph here, unfortunately. But with that c value, again, specifically with the exact value of square root of 9, we know that we are adding and subtracting it to the center y coordinate, right? We need to go up and down here, above and below. So with that, we need our foci to be the center of 3, 5, but then add and subtract this to the y value. So 3, 5 plus root 29, and 3, 5 minus root 29.